হ্যাঁ, লাইভে যাচ্ছে, 30 সেকেন্ডের মধ্যে লাইভ হবে। আমি বিদায় নিলাম ভাই, আল্লাহ হাফেজ। টেক্সট দিন কোনো কিছু লাগবে।
ঠিক আছে ভাই।
ওকে, দাঁড়ান, আমি একদম লাস্ট মোমেন্টে যাচ্ছি। আপনার এখনো কি কোনো কনফিউশন বা কোনো কিছু আছে? আর স্ক্রিন শেয়ার করতে পারেন ভাই, এখানে স্ক্রিন শেয়ার দেখেন অপশন আছে এখানে।
কোন সাইডে এটা?
এই যে নিচে 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 দেখেন প্লাস, ভিডিওর পাশে প্লাস। হ্যাঁ, ওকে ভাই।
ওকে।
আর স্ক্রিন শেয়ার করার সময় অ্যাড টু স্টেজ করে দিতে হবে, যে এটা করে দিন। হ্যাঁ, ওকে ওকে।
আচ্ছা আচ্ছা। So hello everyone, this is Jashim from GraphBit. So today's workshop's topic would be a parallel RAG, rewriting the RAG application in the RAG Rust way. So we'll be demonstrating an stress test, an implementation of parallel RAG with GraphBit and also an comparative framework which is LangChain. So we will compare side by side how much we can stress in terms of parallel RAG. So it will involve like from an end-to-end process, like from starting to document loading to text splitting, chunking, and other RAG-related processes. So the workshop will guide you through how you can stress test that, and on the benchmark result at the end of the comparative analysis, you can see how GraphBit really performs in a parallel pipeline. So let's get started with. So let me first share my screen. So parallel RAG and comparative performance analysis. So what's the motivation behind this? So RAG systems really emerges as a critical technique enhancing large language models applications with domain specific. So, however, RAG systems really very hard to scale, especially in enterprise workloads, processing thousands of millions of documents. So the performance bottlenecks in document loading, text chunking, and embedding processes and vector stores becoming significant operational challenge. Traditional RAG frameworks, particularly those built especially with Python, face fundamental limitations imposed by the global interpreter lock in Python especially, which prevents true parallel execution of Python bytecodes. This constraints result in sequential processing of the document and the RAG systems, and underutilizing the multiple processes and poor scaling characteristics workload size increases. So what are the problem? The big performance gap is the quantity performance difference between an Python-based framework, and a RAG-based, which is GraphBit. So the key differential would be when scaling and production grade, when you have to process thousands to millions of documents. How does GraphBit's throughput scale as document count increases, and exceptionally downgrades the CPU and other computational uses at very low scale? The optimization workaround, the worker configuration, maximizing the throughput of the modern multi-core systems. Document size doesn't impact much when it comes to GraphBit. The cost of the infrastructure really goes also down, up to 90 to 95% less cost. So let's get going. What we can do with the stress testing when building the RAG system, both with LangChain and GraphBit. Okay. Okay. Let me go into the code in details. As you can see, we'll be comparing with GraphBit and LangChain on a load test, starting from document loading and text splitting and chunking. So let's start the pipelines one by one. So you can see the chunking and both the document loading and the chunking process is currently ongoing. So what we have done is starting from one document to going up to the 50,000 documents. So in part iteration, it will go 10 times, starting from 5 to 50, 500, 5,000, 50,000 at most. So current CPU configurations within this limit, we are testing this benchmark suit. So let's wait for the benchmark to run and finally see the result of ourselves. So upon running this benchmarking, let's see what are the measurements and what are we actually measuring through. Okay. So what we are measuring is the execution time, the throughput, documents processed per second, throughput chunking per second, the efficiency of the CPU computation, and also the memory computation. And we have also increased the number of workers per iteration also. So as you can see, the process is currently ongoing. So the features should be the progressive load testing, worker scaling at test, document size scaling, real-time resource monitoring at the end of the benchmarking suite. And we, in the stress test, we are also calculating the maximum throughput, peak CPU, peak memory, and also the average CPU utilization per iteration. So In the current machine, it's currently on a Windows system processor of the Intel 6th Gen, and CPU has a 20 physical cores and 828 logical cores, and total RAM would be just less than 32 GB. Okay. And we are using Python 3.13 for the test. Okay. So incrementally, you can see we are loading the documents per iteration with 100 to 500,000 and 5,000, 10,000 to at max 50,000 for this iteration, final iteration. And for the each of the document, the file size would be 200 to 1,000 words or token per document, the existing ones. And max worker we are using is 20. Okay. Okay. So the performance matrix is we are currently, let's go side by side. So let the benchmark run, and we can also go through the what's been covered in the stress test. So other capabilities covered here would be like the total time, end-to-end process time, and just excluding the network latency, and also the document loading times, the text chunking times, throughput document processing per second completely. So it goes by like loading the document to finally like chunking, splitting, and finally retrieving the query from the document. So secondary matrices would be like the memory uses civilization and the chunks created. So you can see the one benchmark have been completed. Let's go to another one. Okay. Okay. So we just initialize the end-to-end benchmark of the both of the parallel rack implemented both with the GraphBit and also with the LangChain. So you can find it in the benchmark framework comparison pipe file. So as I earlier stated, it will be going through each iteration with 10 to 100 and 500,000 to 10,000 and then finally 50,000 documents processing and end-to-end RAG pipeline. So it's going with each iteration for both of the implemented parallel RAG with ones with GraphBit and one another with LangChain implemented. So it's currently ongoing. Okay, let's wait for to finish up. Okay. In the meantime, let's check out the paper. Okay. So let's check out the already gathered experiment results earlier until the latest ones arrives. So you can see in the benchmark comparison results collected on our remote server, you can see in the benchmark framework table the comparison of throughput and speed. In the columns, you can see the document size, the performance analysis of the GraphBit and LangChain, and the gains based on the speed ups and the times. You can see the like in each of the iteration, whether it's in 100 or thousands of documents, even 500,000, it doesn't really matter. GraphBit still performs 15 to 70 times at on average. It goes like so the comparison would be like 1,000 times more if faster and efficient, and up to 2,000% more efficient, both on the computational and also the speed. Okay. Even with the various document size, you can see it still performs quite a bit, because by time even the file sizes increases and the more load has been stressed out for GraphBit, it doesn't break. Rather, it doesn't compromise with the computational CPU or memory uses. Rather, it like maintains the peaks of the CPU uses and the memory uses, even whether it's a small document or a huge document and a huge quantity of document. Okay. So I think the benchmark results are there. So let's get going. The documents have been saved here. You can see from here. In the terminal, you can see the overall performance. Let's get into the visualizations. Okay, let me open up those. Okay. Let me go one by one. First, so in this visualization, you can see on the left side, on my left side, you can see GraphBit's component breakdown. So we have put on the x-axis the document count, the quantity of how many documents have been processed, and on the y-axis, you can see the time elapsed, time really taken to process all those documents. And on the right side of me, you can see the LangChain's breakdown also, the same in the x-axis and the y-axis, the document count and the time required for processing those documents. It's especially this graph is especially for the document loading and the chunking part only. So you can see that max the time taken for GraphBit is at max 50 seconds, but for LangChain we can see it takes at max over 500 seconds. So the differentiator would be like 10 times more the LangChain takes to execute all these documents. So the highest peak definitely would be the process where 50,000 documents were processed, and the time taken would be just around 60 seconds, including the load time and loading the documents and the chunking. But for LangChain, you can see the process got above 600 seconds, which is 10 times more than GraphBit. So that's one comparison you can see. Okay. So if we go on the throughput count, like how many documents end to end or the RAG pipeline has completed, in not just the document loading and the chunking, but also going for the text splitting parts and the query retrieval parts. You can see the task completion per second on average would be for lang chain, it would be like below like 250 at best. So it doesn't really get much of an like increase in terms of throughput. It doesn't really get to utilize the multi-threading and the like thread-free performance that usually can be easily done with GraphBit's Rust core. And going into the details for GraphBit, uh, in this you can see the highest throughput would be it processed 2.5K documents on the RAG pipeline per second, but on average it would be like thousands, almost 1,000 documents processed for the RAG purposes. So we have like first we got into the breakdown of the time required and the throughput. Then we now got to see the throughput. That means processing end-to-end RAG pipeline it took for per second, how many documents it can process. So the another would be okay. Size. Okay. So even on this, you can see the computational usage, even whether it's in 250K documents or 500K documents, it doesn't matter. The CPU utilization and the memory utilization is really still the same. It doesn't go much peak drastically. So if we go on an analysis, an ROI cost analysis cost comparison on an 𝐴𝑤𝐶5, where it cost 68 cents per hour. So with this comparison, you can see, so even if the number of documents gets increased, that means the number of documents it has to be processed for the RAG system, even if it goes for like 100 to 1,000 or 5,000 to 10,000, even 25 at max, what we have benchmarked, it at max 50,000, it can go beyond. But comparing to lang chains implementation compared to GraphBit, you can see as it doesn't as it's not that much computational hungry, it really doesn't cost you much. So you don't have to like automatically create an or spawn another instance to get the computational resources more and more uh, uh, while getting more documents to process. You can see at max on average its cost efficiency is around 90 to 95% in the current benchmark. So we can see even on the highest number of like stress, GraphBit doesn't break whether it scales properly within the constraint systems. Okay. Let's go into the other details. So what makes actually like GraphBit's performance outstanding? That would be okay. Okay. Let me break it down for you. Okay. Okay. So, okay. Okay. Capacity results. Okay. So the thing would be when it comes to like any kind of rack system. So here we have stressed it and rack system, and we are calling it a parallel lag. So what's happening here is actually like we are stressing out an rack system. So we are demanding the system, whether it's a LangChain or GraphBit, to process into each of the processes to go parallel, a true parallelism. But when it comes to Python-based frameworks like LangChain and compared to Rust-based framework like GraphBit, the key comparison or the key differentiator would be the key lock. So LangChain and other Python-based frameworks really struggles with these kind of constraints. But with GraphBit, so we have engineered in a way that it releases the key lock and the global semaphore. So we are bypassing the entire thread locking and pulling out the multi-threading processes and the true parallelism. But we are not like going out of the way to really get an unsafe processes. So as you can know already, Rust is already type safe. So whether we are utilizing all these parallelism, the system doesn't get into the any breakage. And the other key differentiator would be okay. Let me get it out first. So what made all of these differences? So when it comes to an enterprise level solution, it takes not just one or two documents for a RAG or RAG-alike systems. It requires thousands and millions of documents to process in. But due to all these Python-based constraints of the LangChain-alike frameworks, what they get into the problem is that the increasing memory spikes and unhandled computational resources. So what gets into the bottlenecks is the CPU spikes goes up and up. It doesn't clear up properly, and it doesn't minimize. And what goes on that you have to spawn more resources to allocate all these processes to go run smoothly. But even if to process all these thousands and millions of documents, it doesn't really scale up in production. And what goes at the end is breaking the production pipeline. But with GraphBit, you can see it doesn't consume much of the computational resources, both for the CPU and the memory uses, not even for the random access memories or any kind of memory uses. So what keeps the production very smooth and up and running and utilizing the best of the resources even in constrained environment is that the Rust core of the GraphBit. So it utilizes Rust at the core but has an exposure of Python API to build with. So the developers don't have to write the applications, the AI applications with Rust, rather they can write in the Python APIs, but at the core as it's built on the Rust side, so they get the best of the Rust. So on average, the utilization would be like 10 to 20 times on average, but at max it can be 50 to even higher and up to 100 times max or more. So you are not saving the computation resources, but also saving like the server cost and the infrastructure cost. So you can clearly see that how GraphBit really stands out even in parallel process. And the example clearly we can see in the ParallelRAG system. Okay. Okay. That's basically all from me, and we challenge you to build this kind of application. Like it can be a parallel RAG like system or any kind of which really involves uh, heavy computational processes. So it can be any normal rack system or any application, but we challenge you to build with GraphBit and also with other systems compared to other Python based frameworks. But the key definition at the end you would find yourself would be that GraphBit doesn't break, it stresses more but runs smoothly, and uh, and also saves your planet and also your money, and it scales up very nicely. And so the challenge would be to build with GraphBit, and uh, the and the challenge will go on. And we also welcome this kind of applications you can build with LangChain, but also try out with GraphBit, so that you can see the difference yourself, that how GraphBit really utilizes very efficiently all the resources, whether it's in computational resources or like the max utilization you need to go on the server. And that's it.